This is the 5-4 to 5-5 review, number 6. Calculators still are not allowed. And each of these three are dealing with chain rule backwards and its definite integrals. So what's going to be important here is that you identify your u and your dx. So in this case, I'm looking for something whose derivative is also in there so that I can get rid of all the leftovers. And I can see that log natural of x has a derivative that is 1 over x, so that would probably be a good choice for my u. So if I let u equal ln of x, then dx will be du over the derivative of that, which is 1 over x, or dx will equal just an x times du. So if I do my replacement, I will end up with a 1 over an x times a u times an x times a du. Notice that the x's cancel, so I'm going to end up with a 1 over u, which I know how to go backwards on. Now, because this is a definite integral, we want to see what that upper and lower limit should be. So if I take that e and plug it into my u, I'll get the log natural of e, which is a 1. If I plug in e squared into the log natural, I get the log natural of e squared. That power can come down in front, so I'll get a 2 times the log natural of e, or the 2 times a 1. So now I'm ready to answer the question. What did I take the derivative of with respect to u that gave me 1 over u? And the answer to that question is the ln of the absolute value of u evaluated from 1 to 2. Notice that I don't have to put a plus c on because it's a definite integral, and the definite integral means I can find any antiderivative I want as long as I plug in my upper limit and I plug in my bottom limit. Be careful with this because the upper and lower limits that you plug in need to be u limits. They aren't x limits. If we wanted to use our old x limits that we had over here, we would have to change this u back into the ln of x. So your choice, but I personally think it's more efficient to just change the u's and then stick with the u's and you're done. So in this case, we would plug the 2 in because it's a u limit, and then we'd plug the 1 in, and we end up with an ln of 2. Next, same thing, we're going to choose that ln of x because it will leave me with a u to the third, which is a power rule, and I know how to go backwards on that. And the derivative of the ln of x is a 1 over x, which is also in the integral. So I can write down that u is ln of x, which means that dx will be 1 over, du over the derivative of ln of x. If I simplify, I get dx equals x times du. So now I'm going to substitute in, leave everything the same except for the boxes. The boxes get replaced. If I pull the constants out and cancel, I'll get a 1/2 u cubed du, which I know how to go backwards on. Now, because this is in terms of u, we want to have u limits. So definite integral requires me to change my limits. I plug a 1 in here. Log natural of 1 is a 0, so my lower limit is a 0. My upper limit e, if I plug that in, I get log natural of e, which is a 1. Now I'm ready to answer the question posed by this symbol. What did I take the derivative of with respect to u that gave me a u cubed? The answer is a u to the 4th over 4, and I evaluate using the u limits. So I plug in the 1 first, and then I plug in the 0. So I end up with a 1/8. Last part, C. Going to make the same choice because I know how to go backwards on an ln of u, and the derivative of that u is a 1 over x, which is inside and will disappear when I do my substitution. So I let u equal the ln of x. I let dx be a du over the derivative of that, which if I simplify is x times du. Then I go back to my integral and replace the boxes. Everything else stays the same. And then I think about my limits. If I plug e into my u, I'll have the log natural of e, which is 1, as my lower limit. If I plug e squared into my u, I get a 2 times the log natural of e, which is a 2 times a 1. If I simplify that, get rid of my x's, I have now created an integral I can go backwards on quite readily. What did I take the derivative of with respect to u that gave me cosine? That's a negative sine of u from 1 to 2. So I plug, not negative, positive sine of u. So I plug my 2 in, that gives me a sine of 2, and then I plug in my 1. And I am finished.